Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work, and without any further delay, let's get started with today's topic. Welcome to this lecture where we are discussing extreme gradient boost algorithm for classification problem. In the previous lecture itself, we have discussed the same algorithm but for a regression problem. And it is very important that you have a clear understanding around that topic, just as a prerequisite in order to understand this particular lecture. Not only that, previously we have covered the boosting algorithms like ADA boost, gradient boosting for regression problem, then gradient boosting for classification problem, and right within the previous lecture we have covered extreme gradient boosting for regression problem. And I would say that before you cover this particular lecture, try to cover all these topics. That will help you a lot in order to understand this particular lecture on extreme gradient boosting for a classification problem. I will provide you the link for the machine learning playlist below in the description box. Please consider checking it out. And this is a very simple small data set that we are going to use as a reference in order to understand this topic. This data set has age on the x-axis and got medals on the y-axis. And we are talking around for which age group the athlete did not got medals and within what age group the athlete was able to get the medals. Pretty much simple. So the very first step in fitting the XG boost to the training data is to make an initial prediction. Over here we are considering the by default value, which is 0.5, but remember that this value could be anything for regression and classification, both the problem. And now, just the way we did for a regression problem previously, we are going to fit an XG boost tree to all these residuals. So we are talking about these residuals. First, understand the value for these residuals. Starting from this point, which is 0.5, these two residuals will have a value of positive 0.5 and these two residuals will have a value of minus 0.5. And apart of this, there will be one little change compared to the previous lecture, that the formula to calculate the similarity score is going to be slightly different. So let's cover all these things in details. So what we are trying to understand is, just like the previous lecture, we are going to build a tree which is trying to fit all the residuals from the data set. However, the formula to calculate the similarity score is now going to be changed. On the numerator, we are summing up all the residuals within a leaf node and then squaring it up, divided by, for each and every residual within a leaf node, we are taking the previous probability value, which is 0.5 till this point, multiplied by 1 minus previous probability plus a regularization term lambda. So let's apply all these ideas ahead in order to build the tree. Just like previous lecture, we are starting with a leaf node that will contain all the residuals. And even if you apply this particular formula to calculate the similarity score, the value is going to be 0 because all these data points are actually cancelling each other out. And as we have understood previously in the regression lecture, our next goal is to improve this similarity score. So we are applying a condition of checking age less than 30. If yes, then this will be the leaf node. If no, this will be the leaf node. And these two will be the similarity scores going by this formula. And applying the gain formula, 1.33 will be the gain, which is a sum of 1 and 0.33. And we are subtracting nothing because the similarity score on the root node is 0. Also, there is one more thing to notice, that so far in order to calculate the similarity scores, we have kept the value of lambda as 0. However, this value could be anything between 0 to 1. And as you can guess already, our next step in order to grow this tree further would be to split this particular leaf node ahead. So this leaf node contains the value of this data point and these two data points. So we can understand, if we make a split from this point somewhere between 0 and 20, that would be age 10 years. It will do the job in order to separate these two groups. So let's do that now. There it is. We are applying another condition, and these are the two leaf nodes that we have obtained. Also previously for this node, the similarity score was 0.33. However, the similarity score has been improved at this point, And also if you try to calculate the gain, it will be 1 plus 2 subtracted by the similarity score of the root node, which is 0.33. So this will be 3 minus 0.3, a value close to 2.7. So I will put it here as a gain of 2.7. So we are going to limit this tree up to 2 levels only. This is the first level and this one being the second level. However, when you are solving a real life problem, a tree can grow ahead and have up to 8 to 32 leaves maximum. So after growing the tree, it is important that we talk about the post-pruning technique, and it is time that I introduce you to the topic of cover. So recall that why we were calculating the gain value. If we have a node that we want to split further, then we will try with different splits like this, this and this. And the split with the highest gain value will be the final one that we will apply, and we will ignore the others. And this is how, using the gain value, we came up with this condition and this condition. But after growing the tree, if we have the final leaf nodes, then we also need to decide that how much important this leaf node is in order to make the final prediction. And this is where we calculate the cover value. In very simple words, you need to understand that if the cover value is extremely less for a given leaf node, then we will simply prune it out. Otherwise, we will keep it. As simple as that. No need to go deep down into the technicality. Cover value simply denotes the importance of a leaf node, and it is calculated by this simple formula that we have also used previously within the denominator of the similarity score formula. It is the same thing excluding the lambda term. And since we are talking about this lambda term, let me remind you from the previous lecture that if you increase this lambda value, then it will decrease the similarity score for you. And when the similarity score is decreased, the gain value will be decreased as well. And when you have a lower gain value, then after subtracting the gamma term, you might get a negative value for a particular branch, and in that case you will have to prune it out. This will sound confusing for you if you have not covered the previous lecture. So I am again suggesting that you please cover that topic first, where we have discussed this particular part in details. Okay, so far we have built the XGB tree and we have also discussed around the pruning techniques. Now let's move ahead and understand that how do we exactly calculate the output for a leaf node. So the formula here to calculate the output value for a given leaf node will be again different from what we have discussed earlier. So this one will be the formula to do the same thing. Pretty much equivalent to the formula of the similarity score, but this time you are not squaring up the denominator term. And when you apply this formula for, let's say, this particular leaf node, you will get an output value of 2. And remember, we are keeping the lambda value 0 over here for the other outputs as well. And now that we have calculated the output values as well, let's go ahead and talk around that how do we actually do the prediction. So there will be 3 steps that we need to follow in order to do the prediction. Please do not get overwhelmed by looking at these equations. I'm going to simplify all this for you. So just like other boosting methods, when we are talking about doing the prediction, XGBoost for classification makes a new prediction by starting with the initial prediction. And if you remember, we had the initial prediction of 0.5 that we are going to use now. And we will take the value of the initial prediction and plug it into this formula. So it will be log of 0.5 divided by 1 minus 0.5, which will ultimately become log 1, and it will have a value of 0. In the second step, we calculate the log odds of the prediction. So we will take the initial prediction, which is 0 in this case. So we will say 0 plus there will be a learning rate. So let's consider that 0.3 for the time being, multiplied by, let's do the prediction for this data point. So we will plug the value of the output of the leaf node, that is minus 2. If you do the calculation, you will get minus 0.6. And the last step would be to convert this log odds value that was derived from this equation into a probability value using this particular formula. So it is going to be e to the power log odds, which is minus 0.6, divided by 1 plus e to the power log odds, which is again minus 0.6. So I'm simply putting this formula over here. And if you do the calculation for this, it is going to be 0.35. And I believe that you can already understand, going by this value, that our model is working towards the right direction. Let me explain you how. We are trying to resolve for this particular leaf node, right? Where we have a residual of minus 0.5. We had the residual minus 0.5 over here for this data point, which means the actual value is 0. And the initial prediction for this data point was 0.5. So we were supposed to come down towards this point. And from 0.5, we were able to move the prediction towards right direction by calculating 0.35. So from 0.5, we are now moving towards 0, which is the actual value. And this is how the residual is becoming smaller than before. If you are still confused, then let me do the prediction for you for another data point. So let me quickly erase all of this. And this time, let's try to do the prediction with this leaf node. It has two residuals, both are 0.5. So you can understand that we are talking about these two data points with the residual of positive 0.5, which means the actual value is 1. And let's try to see that starting from the initial prediction of 0.5, if we are able to move towards the actual value, which is 1. So the first step has already been calculated. Using the initial prediction of 0.5, the final value will be 0. Plugging that value over here, the initial prediction will be 0 plus a small learning rate 0.3 multiplied by the leaf output, which will be 2. So I will plug it here and this becomes 0.6. Now, as you know, we need to convert this log odds prediction into a probability value. So I will plug the value to the equation. So we will say e to the power log odds value, which is 0.6 divided by 1 plus e to the power 0.6. And I have already done the calculation for you. The output for this is going to be 0.65. So again, we were able to move from the initial prediction that was 0.5 and the actual value was 1. And now we are moving towards the correct direction with a guess of, not a guess, but with a probability value of 0.65. And this is how the residuals will become smaller and we will create a new tree that will be built the same way, and it will again reduce the error further, bringing the prediction more and more close to the actual value. So I hope that you found the explanation helpful enough to build the understanding around how extreme gradient boosting algorithm works in case of a classification problem. And with this particular lecture, we have covered 5 tutorial videos for boosting algorithm. I think this much information would be more than enough for you to crack any machine learning based interview. It took a lot of effort and hard work in order to create all these tutorials. So in case you found it helpful, please do consider dropping a like below. Subscribe to the channel if you are not yet subscribed. And also consider sharing these videos with your friends or colleague or anyone who may find it useful. Thank you very much for watching the video till the end. You have a nice day ahead.